Hello and welcome. This is one of the more exciting examples that we have in our Infernet Container Starter repository. And the specific project that I'm going to go over is called Prompt to NFT. So pretty self-explanatory. You pretty much type in a prompt, you send it, some image gets generated, and it'll an NFT will get minted with that image. So there's a lot of different components to this. So you basically have some compute that you got to run somewhere. You have to upload the NFT somewhere. And then you also have to basically deploy some contracts that interact with all of this. So this is a really good, Web3 example that sort of showcases end-to-end like how things work. So yeah, without further ado, let's get started. So we can see that there's a Stable Diffusion project over here. We're going to first run that. So on a paperspace instance, I'm going to basically run our Stable Diffusion project. It's basically a small project that loads Stable Diffusion, and you can basically take a look at the code itself to sort of deep dive into it a little bit more. But over here, it's kind of besides the point, and you can replace that with any other service that generates images. So I'm just gonna start it. So it's pretty from the top level directory. If you've been following along with our other tutorials, it's very much sort of consistent with the same formatting. You do make run service, and then you pass in the project name, prompt to NFT, and then the service called Stable Diffusion. So running this, we're gonna basically have that service get started up. It's a Dockerized container, and it's already loading all of the models and stuff, but the models already have been downloaded and they're getting cached here. So we can see that the service got started. So in another tab, I'm going to bring up the rest of the containers. So let's do make, build container, deploy container. The container's already been built, but no, it doesn't hurt to just run the command one more time. It'll get cached anyways. So let's do make, build container, deploy container, project equals prompt to NFT. And then after we run it, we can see that, we don't actually have the config file. And much like our TGI tutorial, we actually need to tell our service where the compute is actually running. So much like there, we also have a config.sample.json file here. I'm just going to copy paste it in the same folder to a config.json file. And the only thing they have to change over here is basically the image generation service URL, right? So I'm going to basically find where the, there we go. I'm just going to replace this with the link to our service that's running on a paperspace instance, right? And another thing that you have to basically make sure that you have, you can see that this wallet directory is get ignored, but effectively because we are, as part of this project, uploading the generated image onto Arweave, you're going to need a key file arweave.json file located here, right? So if you take a look, this is the wallet file, right? So just ensure that you are creating that directory. Otherwise, the build will fail, and as soon as the service comes up, it attempts to load the Arweave file, or like the Arweave wallet, so it'll basically yell at you saying that it doesn't exist. All right, awesome. So with that set and done, we're gonna rerun this command again. Awesome. So that we can see that the Infernet node has come up, it's pulled all the images that it needs, so on and so forth. Let's take a look at Anvil logs. So docker logs -f Anvil -node. Yay, we can see that a typical Anvil node has come up, right? And then next up, we're gonna actually deploy our contracts. And you can take a look at the contract code over here. It's over here. It's basically a typical Foundry project. And we'll go over the code later, but let's deploy it for now. We can, much like any other example, Infernet Container Starter, there we go. Make deploy contracts, and then project equals prompt to NFT. So having done that, we just deployed our contracts. You can see that the contract got created and is at this address. And just to test and see if things are sort of working, we can actually call the contracts directly from the command line here. I actually added a utility. So call contract project equals prompt to NFT. So this is just like a utility script. If you've been following along with the other tutorials, you see the same thing over there. So you can see the transaction's been sent. It's been picked up by Infernet node, right? And the so Paperspace instance has generated the image, and you can see that the result has come back, right? NFT ID is 1. NFT owner is effectively us, with whatever address that I submitted that transaction to. And we can see that the NFT got minted. And if we take a look at the link, it is actually showing us the NFT. So the prompt, that's a picture. But the prompt here is a shrimp dunking a basketball. I should really get more creative with the prompts, but that's basically the default prompt. And you can actually go ahead and take a look at the contracts in the over here. Actually, it's the script contract that calls this. Yeah, interesting. Yeah, the default prompt is a picture of a shrimp dunking a basketball. But you can, change it to whatever you'd like. Awesome. So with that out of the way, let's actually take a look at a more exciting piece of this project. Sorry. All right, awesome. So we can actually bring up the UI project for this. So project, make run service, project equals prompt to NFT, and then the service is called UI. And if you go ahead here, you're going to be able to see the service itself, right? Which is a simple NextJS application. Right now I've used Bun, but if you have anything else, the makefile automatically detects your JavaScript package manager. So we run that, packages get installed, and it runs the UI. So let's take a look at what the UI looks like. All right, awesome. So this is our UI, right? Over here I have a MetaMask setup, and we can see that I have some accounts. Right now by default it's created. It's basically connected to an Ethereum, but we want to connect this to our Anvil node that we're running over here. How do we do that? Well, we basically can, well, first let's connect our wallet. Let's connect, yep. And then we can switch to network. And over here it actually shows the first NFT that got generated in our collection, right? Now, how do we get money on this network? Well, I put this request 1 ETH basically faucet button over here for that reason. So as I'm clicking it, you can actually see some transactions that are being sent over here. But effectively, right now this doesn't refresh, but if I refresh the page, you can see that I have 5 ETH now because I clicked that like 5 times. I can click it one more time, you can see that now I have 6 ETH. All right, awesome. So now let's mint an NFT. So over here, what I'm going to do is the default prompt is a picture of a golden retriever fighting Sparta in the 300 movie. Let's hit generate NFT. Awesome. So we can see that it's a typical MetaMask transaction that pops up. You hit confirm. Over here, we can see that the transaction got sent, right? And coming here, we can actually see that the NFT is being generated. And coming back, we can see that the NFT got generated. So over here, it's just fetching the NFT from Arweave. When you upload stuff to Arweave, either the preview URL for the image is instantaneously generated. Sometimes it just takes a little while, but the image has been uploaded. So we're just gonna have to wait here until the NFT shows up in the UI. It doesn't really take that long. It's usually under 1 minute, I want to say. But yeah, it just keeps trying to refetch, and that's basically what I included in the UI project here. It's just one of those, I guess, annoying things about this, but it's fine. Overall, we can actually separately take a look at this URL. Let's actually do it in parallel. We didn't even need to do that. It came back. But yeah, here it is, a picture of a golden retriever in a, I guess, Greek setting, fighting the Spartans. But yeah, this is our project. So you can actually, over here, you can actually import this NFT onto MetaMask, because MetaMask does have some, MetaMask does have some support for NFTs as well. So let's come down here, back up, blah, 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 blah. This is just a test thing, like ignore, like how can I get rid of that? Whatever. Let's try and import the NFTs. Yeah, it doesn't really allow me. Let's go to tokens, import tokens, and then I'm gonna go and find the NFT address here. So let's go take a look at the NFT address. Boom, here it is. Let's bring the token on contract address. And it took me to the import NFT page. And the token ID for this thing is 2. So I'm gonna hit import. And over here you can see that the name of the NFT is called Diffusion NFT. But you can see that the NFT number 2 belongs to us. So that's just to sort of showcase that you can actually add that into your MetaMask. So this is a pretty good example because it shows you how to run a compute instance somewhere, how to run another service that uses that compute instance, how to upload to Arweave, and how to effectively create a smart contract project that requests compute from Infernet. So any of these pieces, you can separate it out and replace it with whatever you like. If you want to upload the images to S3, you can do so. If you want to run a different model for image generation, you can do so. If you want to add additional capabilities to the smart contract, you can do that. There's pretty much sky's the limit here. And if you want to change the chain to another chain, or like a test net, or even deploy it to mainnet, you can do it very easily over here. Pretty much the same. You would have to just replace the network with whatever network that you desire. Yeah, so that's it. That's our prompt to NFT project. Thank you so much for following along. It's quite involved. It's our, I guess, most complicated example project, but it's really good that it shows everything end to end. Thank you so much, and see you guys in the next video.